Hello, welcome. In this video, we will examine rotational symmetry. You can see I have four figures here that I'm going to rotate on the screen. I'm going to try and show you how to do that a little bit as well with GeoGebra. I have the expanded tools on the left-hand side. If you'll scroll down, there is a rotate tool, but before that, I want to show you a new tool that we haven't talked about yet called the slider tool. It's under the measurements. So I'm going to choose slider. You click somewhere on the screen. It can be anywhere that you want the slider to be. Okay, you can have a slider number, which we could look at later. Perhaps we will. I'm going to choose angle between 0 and 360 degrees. I want you to notice the name. Okay, up here it gives it a name, and it says alpha. It's using the Greek letter alpha equals 45 degrees. If you want to use a different letter, maybe a standard letter of the English alphabet, you can change that. You can always find it in the keyboard as well. Okay, once you do that, it puts a slider in, and you're able to basically then grab that after you've clicked the move tool back and forth between the 0 and 360 degrees. So what you can do is you can tie the rotation of these figures to that slider tool. I'm going to start with the rectangle over here that you see to the right-hand side. So I'm going to go down to the bottom where I have my tool called Transform Tools. One of them is called Rotate Around Point. I'm going to click that. The object is clicked first. Then the point from which you want to rotate around, I put a point in the center there that I want to rotate around. And then when it asks for the angle, rather than typing in 45 degrees or a specific angle, you type in the name that you gave the slider. Mine was called alpha. Now, notice that alpha is not on the keyboard down there. If you click ABC, up comes the letter alphabet. If you use a keyboard letter, that would be handy. Bottom left is a Greek tool, and so I can actually find my alpha there and click OK. So now watch what happens. As I grab my slider now, right, you can see that rectangle rotating. So what your job is to think about when it rotates, when does it click right back into its original position? How many times does it do that in a rotation from 0 to 360? So as I begin to rotate it, notice it's not fitting inside itself until right there. Boom, at 180 degrees, it fits back inside itself. And then all the way once around again to 360. So when you rotate it around 360 degrees, we call that, well, since it went back in the same position once in the middle and once at the very end, we call that rotational symmetry order 2, or it could be also called degree 2, depending on the author you're speaking to. Let's take a look at some other objects as well that will also tie to this slider as well. I'm going to go back and choose my tool, which is rotate around a point. I'm now going to click on the square, the center point, and again, I'm going to change the slider to be the alpha as well. All right. So now the square slides as well. Now that goes really fast, but what you're going to do is think, if I slowly rotate the square, there's 1, 2, 3, 4 times. That's because the square lands on itself every 90 degrees. Okay. So it has rotational symmetry order degree 4. Or degree 4. Let's take a look at the shape in the middle. I've drawn a pretty heart there because it's, when I'm making this video, it's very close to Valentine's Day, and it's a heart shape. Don't worry about how to draw that heart shape. It's not necessarily a part of the course, but it's a cardioid as well. So let's talk about what kind of rotational symmetry order this one has. So I'm going to again choose the tool. I'm going to choose my heart shape, the center, and fix my angle to be alpha. Okay. Let's see what happens. Well, when I rotate, let me go all the way back. Okay, when I rotate this heart, notice it goes around and it's close. But since it has that point at the top, it never clicks back into place until I've gone all the way around. So this one has the most basic rotational symmetry order, which is 1. Meaning I have to do one full complete. I can only, in 0 to 360, only one time does it really map back onto itself right at the very end. Okay. Lastly, you can see I have this orange peel. Or not orange peel, really. Well, it is a peel, but it's really a slice of an orange. So you have like a cross section of an orange. And there's a lot going on there. You can think about the rotational symmetry of this. Let's try it, see what happens. So let's type in alpha for my angle once again. Oops, I typed in A. Again, click the Greek letter alpha, unless you typed A. Now, the orange is really hard to track. But if you were trying to think about how many times it looks exactly the same, you'd have to go really slowly there. Probably an easier way to do it is just count the number of those little individual wedges you can see in there. Inside that orange, you can see wedges of 8. So it probably has rotational symmetry 8.